Welcome to the DIY Honda Garage channel. The DTC P2175 indicates a problem within the throttle actuator control system, specifically a low airflow detection. This can happen when the PCM, or powertrain control module, detects an obstruction or failing component when monitoring the airflow through the throttle body. The throttle body is pivotal in regulating air intake into the engine, and blockages or malfunctions can lead to performance issues. The DTC may be stored if the throttle body blockage rate reaches a predetermined threshold deemed abnormal by the PCM. The symptoms associated with this may include reduced engine performance, erratic idling, or the check engine light illuminating on the dashboard. Following the proper diagnostic procedures is essential for identifying the root cause efficiently and ensuring that any issues get addressed to maintain vehicle performance. The throttle actuator control system is crucial for managing airflow into the engine. An obstruction within this system can lead to an airflow issue, resulting in DTC P2175 being triggered. The Powertrain Control Module, or PCM, is responsible for analyzing signals from various sensors to detect any abnormalities in airflow. The primary component affected here is the throttle body, which regulates how much air enters the engine based on accelerator pedal input. If the throttle body is blocked or malfunctioning, it can prevent the requisite air from entering, which is essential for engine combustion. Common locations for inspection include the intake air duct, air cleaner housing, mass airflow sensor, and throttle body itself. Several potential causes can lead to the triggering of DTC P2175. A blocked intake air duct might restrict airflow, which will be detected by the PCM as low airflow. Another common issue involves faulty mass airflow, MAF, or intake air temperature, IAT sensors, which monitor the air entering the engine and influence the throttle function. If these sensors malfunction, they may provide incorrect data, leading to the DTC being set. Additionally, a faulty manifold absolute pressure MAP sensor can disrupt accurate airflow readings, mainly if it's not delivering the right pressure info. Lastly, an impaired throttle body due to dirt, carbon buildup, or mechanical failures can also be significant contributors to the DTC being triggered. When DTC P2175 is present, you may notice several noticeable symptoms impacting your vehicle's performance. The check engine light is typically illuminated on the dashboard, serving as an initial indicator of a problem. Drivers might experience reduced engine performance, which can manifest as sluggish acceleration or trouble maintaining speed on inclines. Erratic idling is another common symptom, where the engine might fluctuate in RPMs unexpectedly, causing rough engine behavior. Lastly, poor acceleration response can indicate that the throttle body is not functioning properly, resulting in delayed reaction when the accelerator pedal is pressed. Recognizing these signs promptly can help in addressing issues before they escalate further. The first troubleshooting step involves setting the vehicle to the on mode without starting the engine. This step is crucial as it allows the diagnostic system to be calibrated and ready for feedback. Once the vehicle is in this state, it is important to ensure that the engine has cooled down to 77 degrees Fahrenheit, 2,500 Celsius or less, which helps in obtaining accurate readings from sensor data. After confirming the proper conditions, the engine can then be started and idled for a minimum of 10 seconds. During this idling period, monitoring the Honda Diagnostics System, HDS, for the reappearance of DTC P2175 is critical in verifying whether the issue persists. In the second troubleshooting step, a thorough inspection of the intake air duct and air cleaner housing is essential. This part of the intake air system plays a pivotal role in the airflow to the engine. Any blockages at these locations can lead to low airflow issues. Inspecting these areas visually allows the technician to check for any debris or obstruction that could hinder air intake. It is important to ensure that conditions at the connections are normal, meaning no cracks or disconnections that might allow unmeasured air into the system. If abnormalities are found during this visual inspection, it signifies that further attention is required, potentially indicating that the intake air system components need maintenance or replacement. The third step in the troubleshooting process focuses on conducting a functional inspection of the intake air temperature IAT sensor. Before beginning, record the ambient temperature as it serves as a baseline for comparison. Once the vehicle is switched to the on mode, the technician needs to quickly note the readings from the HDS for the IAT sensor. The objective is then to compare this value against the recorded ambient temperature. Under normal conditions, the difference should be less than 5.4 degrees Fahrenheit, 3 degrees Celsius. If the values deviate significantly, it indicates that the IAT sensor is potentially malfunctioning, leading to incorrect airflow information and thus triggering the DTC. The fourth troubleshooting step entails inspecting the mass airflow MAF sensor. Start by idling the engine while ensuring that the engine coolant temperature ECT sensor reading exceeds 158 degrees Fahrenheit, 70 Celsius. This temperature stipulation is vital as it allows the engine to reach a stable operating state. With the engine in park or neutral, the technician should aim to hold the engine speed at 2,500 RPM for a time period of 30 seconds. Throughout this duration, monitoring the HDS for the MAF sensor reading is important. Normally, the values should fluctuate between 4.1 grams per second and 5.7 grams per second. If the readings are outside of this range, it signifies a malfunctioning MAF sensor that needs further investigation. The fifth troubleshooting step involves the manifold absolute pressure MAP sensor functional inspection. Start by turning the vehicle to the on mode to activate the electronic systems. The technician should then compare the readings from the MAP sensor against the turbocharger boost pressure, TC boost pressure. The acceptable condition requires that the difference between these two values should be less than 26.7 kilopascal, 7.9 inches per second, 200 millimeters per second. If this difference is greater, it indicates potential failure within the MAP sensor that could impact the air intake management. Confirming the proper functionality of this sensor is crucial as it directly affects engine performance. In this sixth troubleshooting step, the API, Application Programming Interface, is engaged to delve deeper into the MAP sensor's functionality. After turning the vehicle to the on position, the technician will record the value returned from the MAP sensor before starting the engine. Once the engine is operational and idling, it's crucial to compare the previously noted value to the new reading. A properly functioning MAP sensor should demonstrate a change of 0.67 kilopascals, 0.2 inches, 5 millimeter inches, or more from the initial measurement. If there is insufficient variance, it signals fault within the MAP sensor, affecting engine performance and successful diagnosis of the DTC P2175. During the seventh troubleshooting step, a functional inspection of the turbocharger boost sensor is performed. Begin by ensuring the vehicle is in the on mode, which prepares the vehicle's systems for monitoring. The technician will then need to compare the turbocharger boost pressure reading against the barometric pressure sensor, which also plays a significant role in air density calculation for optimal engine performance. Under normal operating conditions, the difference in values should be less than 26.7 kPa, 7.9 inches, 200 millimeters of mercury. Should the values diverge significantly, it indicates a potential malfunction within the turbocharger boost sensor. Accurately diagnosing this step is critical to rectify any issues affecting the vehicle's throttle and airflow regulation. In the 8th troubleshooting step, the technician will return to the turbocharger boost sensor to further explore its functionality. To begin, the vehicle should be in the on mode, and the technician will note the initial TC boost pressure value displayed after starting the engine. Once the engine is running, attempt to maintain an idle speed at 3,000 RPM without any load until the radiator fan engages. After this, it's essential to hold the engine speed at 4,500 RPM for approximately the same duration. Observing the TC boost pressure during this transition is crucial. A healthy turbocharger boost sensor will show a variance of at least 0.67 kilopascal, 0.2 inch per second, 5 millimeter inch per second, or more from the noted value. Any discrepancies here suggest an issue within the sensor affecting vehicle performance. The 9th step involves testing the throttle actuator control system through the ETCS, Electronic Throttle Control System test. This test is fundamental for ensuring the throttle body is responding appropriately to driver inputs and electronic signals. With the HDS in use, the technician will initiate the ETCS test to evaluate the throttle actuator control valve directly. Expectations during this step are strictly governed by normal operational parameters. Should the actuator control valve output remain within these constraints, the throttle body is confirmed functional. However, if abnormalities are flagged during testing, this indicates that further analysis and potential repairs or replacements may be needed in addressing the DTC P2175 effectively. In the final troubleshooting step, attention is directed towards a detailed visual inspection and cleaning of the throttle body. To begin this process, the technician must disconnect the throttle body inlet hose for access. It is essential at this point to thoroughly clean the throttle body of any dirt, carbon buildup, or other debris that may have accumulated over time, as these obstructions can significantly affect airflow and performance. After cleaning, the technician will inspect the throttle valve and bore for any signs of damage, which could impair functionality. Normal conditions dictate that no dirt or significant damage should be found. If anything irregular is noted, a replacement or further repairs may be necessary to ensure proper functioning of the throttle assembly and eliminate the DTC P2175. After completing all troubleshooting and repair steps for DTC P2175, it's imperative to carry out a final verification to ensure all systems function adequately. Start by taking the vehicle for a test drive to gauge real-world performance and responsiveness. During this process, keep an eye out for any reappearance of the DTC that may undermine the previous repairs. Monitoring engine performance is equally vital. The vehicle should accelerate smoothly without any hiccups or loss of power. Additionally, verifying that all components function within their normal parameters ensures that the vehicle maintains an optimal operational state, reinforcing the effectiveness of the repairs conducted to alleviate the issues signaled by DTC P2175. Preventive maintenance plays an essential role in avoiding future occurrences of DTC P2175 or similar issues. Regular inspections of the intake air system are crucial, ensuring the intake air duct and air cleaner housing remain clear of blockages. Establish a routine for cleaning sensors, including the MAF and IAT sensors, as fouling can lead to incorrect data and performance issues. It is also advisable to include throttle body maintenance in your maintenance schedule, as cleaning this component can prevent carbon buildup that interferes with airflow management. Lastly, periodic performance monitoring can catch deviations before they escalate into major problems, helping to maintain vehicle reliability and performance. In summary, DTC P2175 represents a serious concern regarding the throttle actuator control system and low airflow detection. Understanding the roles of various components such as the throttle body, MAF sensor, IAT sensor, and MAP sensor is crucial for effective diagnosis and repair. Each troubleshooting step plays a critical role in isolating the issue and addressing the root causes. Timely intervention, thorough cleaning, and appropriate sensor inspections can significantly enhance the overall performance of the Honda Accord. Adopting preventive maintenance measures allows for sustained reliability, ultimately contributing to a smoother driving experience and prolonging the life of the vehicle. Please like and subscribe to the channel. See you next time.